So the last group of problems, 15 through 20, give me a new formula called the compound interest formula. And this formula can be used if you are saving money in a bank or some financial institution where you're getting periodic interest. So the formula that's given in problem 15 through 20, it's not written in function notation, but the formula for 15 through 20 is used to figure out how much money is going to be in a savings account at some point in the future, given the interest rate, the length of time that it's invested for, the amount of money that's invested, and how often interest is being paid. So for this formula, the A in this formula is the future amount of money. So the future amount of money that I'm going to have can be found by taking the P, which is going to be the starting amount of money, the dollar symbol, I'm not sure it looks like a dollar symbol, times 1 plus R, and R is going to be the interest rate that you're getting, the decimal form of the interest rate. The N is the trick. The N is how often interest is paid each year. And I'll talk about that in a second. And the T is usually the number of years, usually when we're saving. The time unit is measured in years normally. So most of the numbers are really straightforward, except for this N. The N, how often interest is being paid, is often written with a word and not a number. So for my N's, if I see the word interest is paid annually, I don't know if I can even spell annually correct. I'm like a moron. I think it's 2 N's and 2 L's. If interest is paid annually, N is equal to 1. If interest is paid semi-annually, N is equal to 2. If interest is paid quarterly, then you're getting interest 4 times per year. If interest was paid daily, N would be 365 because there's 365 days in the year. So the N is how many times the bank is going to pay you interest. If you're getting, like, if I'm getting 4% interest and it's paid twice per year, that's every 6 months I'm going to get 2% interest. I get 2% interest twice per year to make my 4% interest, for what that's worth. I could give more detail, but then it's going to make the video go way too long. So if I wanted to do a problem, any of these problems between 15 and 20, it'll start off, it'll give me a starting amount of money. So in 16, an initial deposit of $1,000 earns 3% interest compounded twice per year. How much will be in the account after 10 years? The first number I'm going to be given is going to be the P. It's the initial amount of money. So for this problem, number 16, the initial amount of money is $1,000. It earns 3%. That's going to be the R. And again, I need to make that into a decimal. And then compounded twice per year, that's what the N is. It's semi-annual interest. And compounded means paid in some sense. The interest is paid twice per year. How much will be in the account after 10 years? That's going to be the T, which is time. And it doesn't say how to round, but because it's money, I'm always going to round to 2 decimals for money. So the amount of money A that I end up with is the starting amount of money, which is $1,000, times 1 plus, just using the formula, R, which is 0.03, over N, which is 2 for twice a year, to the N times T power. So I just took the numbers, plugged in 0.03 for R, For both the n's I plugged in 2 and for the t I plugged in 10. I'm going to break out my calculator and do 1,000 times 1 plus fraction 0.03 over 2 to the 2 times 10 power. My calculator gives me 1,346.855. I round around to 2 decimal places. So this 85 cents is either going to remain 85 cents or it's going to bounce up to 86 cents because the number after it is a 5, which is qualified for 5 or bigger. I'm going to round it up to 86 cents. My answer for problem 16, the amount of money that's going to be in this account is $1,346.86. Your problem 15 should work exactly the same. If you are doing problem 15, the future amount of money that you're going to wind up with is equal to the starting amount of money, which is $1,000. That's going to be your P. Your R is going to be the decimal version of 4%, which is 0.04. The N, interest is paid twice per year. And how much will be in the account after 5 years? The T is going to be 5. So the formula that you would use in problem 15 would be that. And since I've got my calculator here, you just go 1,000 parentheses 1 plus fraction 0.04 over 2 to the 2 times 5 power. And I'm going to round that. Well, I don't need to round it at all. I'm just going to say it's $1,218.99. 17 and 18 are essentially the same problem. Ask me to use the same formula. The words are the same. I just changed the numbers. So I read through my number 18. Initial deposit of $20,000. That's going to be the P. Earns 3% interest. That's going to be the R, but I'm going to make it into a decimal and make it 0.03. Earns 3% interest compounded quarterly. There's 4 quarters in a year, so this interest is going to be paid. You're going to get 1/4 of a year of interest 4 times per year. How much will be in the account after 17 years? That's going to be my T. So I'm going to use this formula. The future amount of money I'm going to wind up with equals the starting amount of money, which is $20,000, times 1 plus the decimal version of the interest rate, which is 0.3, over how many times I'm getting interest each year, which is 4, to the n times t power. That's the numbers I'd shove into my formula. I'm going to round to the nearest dollar, so I'm going to go $20,000 times 1 plus fraction 0.03 over 4 to the 4 times 17 power. And that's just going to round perfectly to $33,242.50. Should pause the video and do 17. I'll write down some work so I don't have to look at the answer. This is going to be A is 10,000 times 1 plus 0.06 over 4, because the N is going to be 4 because there's 4 quarters in a year, and this says interest is paid 4 times per year, to the N times T power. I think yours is going to be $12,327, and I'm going to round that to 12 cents. The 11 cents is going to round up to 12 cents because the 7 after the 11 cents tells me to round it up. And I usually write these answers just with a dollar sign. All right, 2 more problems, 1 of each. Same problem, just different numbers using the same formula. So for my problem 20, an initial 200,000, which is my P, earns 7% interest, which is my R, but my R needs to be the decimal version of that, 0.07. Earns 7% interest compounded semi-annually. Semi-annually is twice per year, so the N is 12. How much will be in the account after 15 years? That's going to be my T. For my problem 20, I'm going to say the future amount of money is the starting amount, which is $200,000, times 1 plus r, which is 0.07, over n, which is 2, to the n times t, which is 2 times 15 power, and I would just enter that on my calculator. For your problem 19, an initial deposit P of $100,000 earns 4% interest, which is 0.04 for the R, compounded annually. That means the N is 1 per year, 1. And how much will be in the account after 5 years? The T is going to be 5. For your problem 19, the future amount of money that I end up with is the starting amount of money, which is $100,000, times 1 plus, and then the R, 0.04 over N, which is 1, to the N, which is 1, times T, which is 5 power. For your problem 19, 100,000 times 1 plus fraction 0.04. I don't need the 0 to the left of the decimal if I don't want it. And, whoa, forgot the decimal here. I don't have the decimal to the left of the 0.04. So I'm going to say for number 19, you're going to wind up with $121,665, and rounding to 2 decimals because it's money and 29 cents. All right, so that's the end of all the new material. So we just need to get through the practice test. So there's just the graphs from section 7.1, the solving the equations using the prime factoring in 7.2, and these word problems in 7.3, and that's all of chapter 7.